All right, guys, I'm experimenting with my new ring light and stand, and I actually have a cool little remote to start and stop the stuff. This activity is 213 free body diagrams. And it's really changed over the years. It used to be more of a PowerPoint lecture, work your way through. It's switching up to be more kind of online taught, and I am converting it to kind of our way of doing things. So you've got the notes from me. Now you have to do the application. So for the application, you're gonna have a couple things I want you to make free body diagrams out of. You're gonna do a fishbowl and a stand. You're going to do some logs and a stand for a fireplace. You don't have the fireplace, but you just have the logs and the stand, and how the logs and the stand interact. And finally, you interact with like I said, I've got my notes over here. You interact with a traffic light that's hanging from rings. You'll see all that. The big key here is to break it all into its individual pieces and then show me all the forces that are interacting on that particular object. Now this is going to be important when we're kind of moving into bridges here, and I want to get you to where you can take each point on a bridge and figure out what forces are acting and reacting on that bridge so you can do the math to figure out how to do that. But you're going to miss stuff if you don't even know what you have to do the math on. That's where we're going. We're not there yet. We're kind of slowly building our way there. So this is going to transition after I end this video, and I actually made videos of me as normal kind of helping you through that. So if you want help through that, then continue going. If you don't want me to spoil it and you want to give it a try, then pause the video here and give it an attempt. For the fishbowl, so here we have our fishbowl, here we have the stand. We're gonna break it down into two pieces. We'll just make it a circle and a square. Okay? Now we know that the fishbowl has weight, right? That's a force. It's the force pulling us down. So there's our weight force, right? Well, for every action equal an opposite reaction, there's the force going up. That's the force normal, the normal force, or the reaction force to the weight going down. All right, that's fishbowl done. And well, the stand is pretty easy too. There's the weight of the stand, and I gotta I gotta adjust this so you guys can see it. So let me redraw this. I'll draw this as a tiny box so you guys can see here. So there's the weight of the stand, and then there's the force normal of the stand. Weight and then force normal. So there's the reaction force. So these so far are the same, but there's one thing different about the box here, and that is the stand here also is dealing with the weight on top of it of the fishbowl. And I guess technically, if you have these two next to each other, you could say that reaction force there is up there, and shouldn't you have another arrow coming up here? You probably should, but we're going to get away with it this time. All right, that is what I expect from you for the fishbowl. Okay, second example. I'm going to bring this down just so here. Let me come up to the corner. We'll draw this. We have like a fireplace stand here, and we have a log here, a log here, and a log here. Okay. Now, trying to remember my picture here, and it does not look like these two are touching. So I think we go like this, right there. Okay, yeah, that's how it is. Okay, good. So we have log 1, log 2, log 3. 1 and 2 are touching, 2 and 3 are touching, 3 in the stand in 2 places, 1 in the stand in 2 places. Okay, so there's kind of our horribly drawn rough example here. So let's break this down one object at a time, because free body diagrams, we break it down at a time. So what do we have here? We have 1. Okay. And I'm going to do 2. And then I'm going to do 3. Now the reason I'm doing it this way, I'm trying to kind of show you better how this works. So, and I know that the stand is kind of like this. So hopefully you can see how this works. So for log number 1, I know that there is a force because log 2 is touching it, right? So there is a force here from log 2. We know that the weight of gravity is pulling it straight down into the stand, and I know that the stand is pushing straight up back. I also know that it's touching here. Now, it's obviously, it would help if I kind of drew this better. There we go. Okay, so now I know that there is a force of the stand actually pushing on log 1. So these are all the forces interacting here with log 1. If I go to log 2, well, let's think about this. Log 2 is touching log 1 kind of at an angle here. So I know that there's a force coming from, like a reaction force into log 2. There's also a reaction force, if you look here, from log 3. Where's the bulk of the weight going? Straight down. So that'd be the force going down for log 2. Okay, what do we have for log 3? Well, log 3 is getting pushed on here, here, and here, but not on the side there. So I know that there's a force coming in this way from the stand. I know there's a force coming in this way from 2. And I know there's a force going straight down from 3. But there's also the reaction force coming back up from the stand. That's that normal force pushing back up. All right, so that's 1, 2, 3. And what do we have with the stand? Well, we know that there's also a force pushing reaction this way, right? So for every action, there's an equal and opposite reaction. So there's one pushing this way. There's a force pushing that way. Okay, there's we kind of already drew them here, but if I wanted to draw them kind of as a separate arrow, there's a force pushing up here. So if you were drawing this completely separate, this is what you would draw: arrow, 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 arrow. And then what else do you have? Well, the stand is sitting on the ground, right? So it has the force of weight and then the force of the normal force, the reaction force, that's holding kind of all this up. So that's how you would diagnose, draw out the logs. So I get it up there so you guys can see everything. I hope I didn't just draw in the dark, but I'll kind of keep it alive there for just a second. All right. Okay, we have a stoplight that is hung on some rings. So let's kind of per our norm here. Here's that bar. You have a ring, you have cable, and then that attaches to your stoplight box here. So there's your stoplight. All right, I am not the best artist in the world, but I know that we have to diagnose the ring 1, the ring 2, the cable 1, the cable 2, and we have to do the light itself. Okay, so we have to come up with the force diagram for all of these things here. Well, let's see, free body diagram, right? So let's start with the ring. So if I have a ring here, and I have a ring here, we'll keep them separate, but I think the orientation helps us. Now, there is a force pulling this way on these rings. For every action, there is an equal and opposite reaction. Force gravity, force normal. It's the opposite reaction. Okay? Now, there's also the cable here. Maybe if I kind of draw it like this, you can see that it's a cable. And I'm not trying to confuse you. I'm just trying to show you that this is maybe a braided cable of some kind. And it has, well, it's got a force being pulled on it this way. What, by the stoplight? Well, there's an opposite force getting reacted to that way. Okay? For every action, there's an equal or opposite reaction. And let's kind of pull this up here. And then there's our stoplight. Once again, I'm going to make it a small box because I'm running out of screen. And what does the stoplight have? Well, it has this reaction force because we have to counter these forces, right? And then it has the force of gravity down. Now, I can't have a normal force up because it's actually not touching the ground. So there's no normal force to respond to that force. But there is here, here, and up here. So that's how you would do the stoplights.